actually, most of my content or the topic covered by Shravani, I'll take from how do we deep dive into that. So, actually, wherever we work, we start with these questions, or we think about these because everyone is here. We face these issues day out, in our daily life. So all the losses, how do we reduce? Everyone has our own methodology to reduce these losses. So how do we improve that? But before that, it's a simple start mixing and the short circulation system. What are we missing in terms of AA? So we all know we have a lot of data from the machine, and we have a mathematical models or whatever the AA called. So where are we missing there? Because here in this situation, in this process, we have a refinance, and then we have a blending, and then we have a mixing, another mixing there, and then we have short circulation, and then we go there. But if you see here in the mixing, we are mixing different fibers, and this is one of the, maybe if I say the number wise, if you have a 1% level variation at mixing, it will give you more than 25% fiber development problems or fiber mixing problems. So that is not the experience. This is one of the important parameters, different fibers, how we are mixing. In here, this is another block area or block box. This is one of the important where we mix thick stock into thin stock. Here, if there is a variation, we don't have a data to understand whether this gives us MDCD variations or is there any delays in the machines. This is one of the area we don't have a data. And here we know this area is almost block box. We have only the centricliner and the pressure and few flows. We don't have any data about this. And then another mixing. One mixing different fibers, another mixing thick stock and thin stock, and here we are mixing pulp with chemical. And then that dynamics, that chemistry, we don't have a data to understand. So when we miss these data, if we don't have a data, then how AA can understand that? That is a major issue which we have now. We are all working on to get some information and understand those points to improve our productivity or the variations or the break problems. So few slides are really standardized standard slides. Maybe I will go through very quickly here. We have all the data. We know TCS data, drives, conditional monitoring. All the data are available in a different way, different format, different frequency. But and they are all in silos. Okay, here the one important point here, in day-to-day life, the operators are taking lot of decisions to improve the process performance, or if any break, they have to take some decision to reduce the breaks. But with this data, operators are really struggling to understand what data is that, what mathematical inside it, how do we improve them. So here, what we should do, this is another standard slide. I am going through the data we already have, and then we are processing it. I think our web industries are little heard in this area, and then we have a big data analytical layer where we have some tools like AVP has shown now. A lot of tools are available. We have up to that we have some data. Then after that, how do we run this AI to understand this process? So again here we have some inputs with the data, and then we have some methodological or mathematical calculations, and then we have some outputs. As far as output means the improvement or the productivity or the business, there's a number. But for me, here it's a decision. How we take decisions. Whether, especially I'm talking about the operator level, each and every instance they take a lot of decisions. A day, thousands of decisions they are taking. Whether that decision is right or wrong. Can we give some inputs to the operator to reduce the errors or reduce the bad decisions? That is what I'm just thinking in terms of AI. So what we do? We are just kind of, we are trying to give some assistance for the operator to take the better decisions. So here, this is an example I'm kind of showing here. If they have a variation, or MD variation, or CD variation, or break, or whatever higher consumption, if we have any questions, let operator ask the question. The same way, whatever the analytical data is there, analytical, mathematical calculations are there, and we are converting them into meaningful information for operator to take a better decision. For example, here any questions, and then there is a contextual retrieval where the paper brain should be there. What data we should analyze? What is the sampling size? What is the duration? All of them they have to understand. The tool should understand. So that is what the brain is all about. Then from here we do exactly, we take the exact data, analyze with the mathematical numbers. That number should go to the reasoning mind. That reasoning mind, you all know that you can take any ChatGPT or Claude. They have their own reasoning, the language models. That number can be converted into meaningful information on layman language like operator language. So then we give some solutions. So if you have a basic problem, you adjust, maybe the silo levels are varying, so you have a weight variation or moisture variation, something like that. So this is how I'm trying to work in this manner. But quickly I'll go through this. Most of them standard tools available in the market already. What I try to do here is, for example, I'm thinking in terms of process. Earlier, Shravani showed in terms of a control perspective. Here I'm thinking about a process perspective. For example, in stock preparation, we have n number of equipments, n number of transmitters and the controls, whether they are working or not, in wet and in dry. So in process perspective, we are looking at, this is standard tool which already available and already established in the market. And just example, this is one of the tool which everyone has. Any QCS, if you go to any quality control system, you have this color band. But if you see in the operator, if they have a backside goggling or creasing or piping, whatever you call it, and then our operator is using this data to take decision, or instead of using the data, they see the creasing and then they go and adjust the calendar or the press or whatever it is. Are they taking the emotionally with experience, or are they using this data? But here, this is very simple color map I'm showing. We have multiple other data, other mathematical ways to understand this. For example, here the same color map I'm just showing in the amplitude spectrum or power spectrum. It's a very simple calculation. When you see the power spectrum, there is a red line. That red line is the cutoff frequency, which is our existing equipment. Whether existing equipment will be able to solve this problem or not. That is a simple analysis. The left hand side, if you have any variation at the left hand side, any frequency at the left hand side, the existing equipment must be able to solve. Right hand side cannot solve by existing equipment, but we will know where it is coming from. Whether it is coming from vacuum or head box, whatever it is. We will be able to know that. From there we should take one paper maker, should take some decisions. And you don't have to do this type of analysis. Operator cannot understand. Maybe one quality operator may understand, but these numbers, they cannot correlate with the creasing or back-end problems or the paper problems. So what we should do, we do the analysis at the back, we give them in a layman language. Go please adjust, reduce the slice, or you adjust your calendar, something like that. So we can do this because all are data based. Same way, maybe already she showed. Again, it's a proven concept. Without doing some test, we have three kind of the tuning parameter identification. One is with the existing data. We have a MV, SP and output. You see the data and then you will be able to find, but that is not that accurate. That's what the auto tuning function already available in the QCS. It is not that accurate because of many interactions. And then we have a closed loop time. You do any set point change, you will be able to find. That is another level. But if you do the manual test, you will be able to understand exact numbers. So all these functions, for example here, I am just trying to show another way of another function like grade change, where we lose some money. Because when you change the grade, if it takes longer time, you are losing money. Same way, it should analyze. The data are there. When you change the grade longer, who is creating problem? Whether it's a stock or consistency or something else, or the tuning. So this tool or whatever the numbers, the calculation will be able to understand that, and then it will tell you what happened. During this grade, what happened? What is the recommendation for this? You have an action plan. Then operator can understand, oh, this grade change is bad, so what we should do at before, the next grade. We can understand that. Somewhere maybe this is very simple identification in the break. This is about one example I am just talking. For example, this you may be looking at this kind of a slide everywhere. If you see the break, before that some chemical started varying. So we know that by putting some 3 sigma out layer, you will be able to understand that. But same way, we can identify the many parameters is there. That calculation already established. We all know that. We understand. We take that calculation, then you can find out and then give the some recommendation for the operators. And again, here it is somehow it is a dashboard. I'm not fan of this dashboard, but still, all industry people look at the production problems or loss panel or something like that. But it is all the solutions are available at the front end. How the process is, how the signal is, how the design is, whether they are good or bad. If it is bad, obviously production summary or losses panels are bad. If they are good, it is good. So that is why every day you have data, analyze, understand, and then you can take some solutions. So this is one small case study. We know, as I always say, it is not one day job or 1 month job. For example, the first one I am showing some tonnage. This is one of the biggest mill, maybe 1,200 tons per day capacity. The average production or average rejection was around 500 tons per month. And then it came down to 100. But it is not in a one day. So we put that tool and then we understand every day there is a remote, monitoring. So we monitor. Every day we take the decision by export plus by the export tools, something like that. And same way the brakes. You can see these brakes. It is a 1 year we work. We see kind of all this work, kind of a post-mortem analysis. After the read, we collect the data, we do it. After 1 day, we collect the data, we do it. It's a kind of a post-mortem. But you will be able to understand a lot of things at the back. The same way, it is not, we are not at the, far away from prediction. If you do this rightly, prediction is very, very near. Yeah, almost I'm done.